This video was made possible by Hover. Professionalize your web presence with a custom email address for 10% off at hover.com/Wendover. This is the two-page document that changed the world. It's what's referred to as a notification to the World Trade Organization Committee on Technical Barriers to Trade, a type of document that, to anyone in the know, is thoroughly mundane. In fact, every few hours, another such notification enters the WTO system, each signifying that yet another country wants to make yet another change to its rules regarding the import or export of goods or services. This particular notification, though, submitted on July 18, 2017, managed to send the entire global recycling industry into a tailspin, or possibly even a death spiral. Put simply, this document broke the world's recycling system. But here's how it worked before this document. Let's say a woman in Littleton, Colorado, has yogurt for breakfast. The yogurt is packaged in a thin polypropylene plastic container, and so, once finished, she disposes of it into her recycling bin. This is then picked up by a recycling truck a few days later and brought here to the local recycling company's materials recovery facility. There, this yogurt container, along with all the rest of the single-stream recycling picked up that day, is dumped out and placed into the semi-automated sorting system. Some products are simple to isolate. Most metals, for example, can be picked up by magnets, while paper and cardboard can be easily sorted by density, as they're typically lighter than other recyclables. Glass, plastics, and non-magnetic metals are a little more difficult to sort, but each looks quite distinct, so optical scanners operate blowers or other diversion tools that are able to sort these out. With a few more steps, the facility is more or less left with just plastic, but that's where things get difficult. Plastic comes in all sorts of shapes, sizes, and types, and different shapes, sizes, or types of plastic are recycled in different ways. Optical sensors start out by at least accomplishing a high-level sort, though. For example, in many US states, plastic bottles are sold with a 5 or 10 cent deposit, meaning that recycling companies put a lot of effort into recovering those from the mix, as they can be sold for, at least relative to the other plastics, a lot. They also put a lot of work into recovering certain plastic types, such as high-density polyethylene, as this both sells for more and is easier to sort out of the mix since it's typically used to make larger items like plastic crates, shampoo bottles, and other products where sturdiness matters. The polyethylene and other higher-value plastics are quite accurately sorted and then melted down into bulk raw plastic, which is resold to manufacturers. Certain other plastics, though, have a negative value. They can't be sold, and in fact, it would take so much work to turn them into usable raw material that recycling companies would have to pay someone to take it off their hands. Typically falling into this category are smaller items like bottle caps, plastic bags, and other scraps below 3 inches or 8 centimeters in width that just can't be easily sorted by automated systems. These are then aggregated together and, at best, used to generate electricity through incineration, or, at worst, are just sent to a landfill. So, to summarize, there's high-value plastic that's recovered immediately, negative-value plastic that's either incinerated or sent to a landfill, and then there's a third category in between those two, and that's where things get interesting. Anything that isn't small and unrecoverable or large and valuable is typically mixed together and formed into big bales of unsorted, medium-size, medium-value plastic that effectively have a neutral value on the free market. The raw materials in these bales, known as MRF residuals, is not quite valuable enough to pay for the sorting process they would need for recycling, which leads to their neutral value, at least in the US. After it takes its trip through the materials recovery facility, that yogurt container from Littleton, Colorado would, if properly sorted, end up in one of these MRF residual bales. These are then loaded into the back of a semi-truck driven 1,000 miles to the port of Long Beach, California. There, the bales are officially exported from the US, loaded into a shipping container, and placed on an enormous, yet empty, Hong Kong-bound cargo ship. Now, with this knowledge, some might ask a question. How on earth did we end up with this system, theoretically designed to reduce our impact on the world, where our waste is shipped across the world? To that, there's actually a surprisingly specific answer. Decades ago, in 1969, the first National Conference on Packaging Waste convened, and in that room were a number of plastics industry executives. Throughout that event, they heard municipal leaders from around the country express their concern about just how permanent plastic was. Back then, the material was becoming cheaper and cheaper and was quickly gaining prominence in the packaging world, but this mounting concern among municipal leaders itself led to mounting concern among plastics executives. They came to believe that this plastic hesitancy would quickly become an existential threat for the industry's growth, so plastics knew they needed a solution. They needed a way to make plastic sustainable. The problem? There wasn't one. So, backup option. Rather than creating a real solution, they willfully and knowingly created and propagated a system that didn't work but looked like a solution: recycling. From a technical standpoint, you can sort, melt down, and reuse plastic, thereby reducing its impact on the world, but that's not why it doesn't work. From a social perspective, people do often do their part and, at least somewhat, separate their trash from recycling, but that's also not why it doesn't work. Why recycling doesn't work is because, overall, it's not profitable. It's very simple. Oil is cheap, at least now, and when oil is cheap, making new plastic is cheap. Meanwhile, sorting, transporting, and melting down existing plastic is expensive. In 2017, virgin PET plastic cost about 54 cents per pound, while recycled PET cost about 63 cents per pound and was lower quality than the alternative. Therefore, demand for recycled PET was low, so waste management companies couldn't turn a profit turning used PET into raw recycled PET at scale. When companies can't make a profit recycling, it doesn't happen, or at least not at the rates needed to make the plastics industry sustainable. For the plastics industry, though, all they needed was the perception of sustainability, and even though a big chunk of what went into a recycling bin ended up not recycled, consumers and municipal leaders were happy because they believed that the plastic they consumed was guilt-free. That's how that yogurt container tossed in Littleton, Colorado ended up on a boat to Hong Kong. Now, the rule just mentioned is still valid. Plastic is only recycled when it's profitable, but for a brief moment in time, it was, all thanks to a trifecta of economic conditions in China. First, shipping was incredibly cheap. Western nations like the US have long had a significant trade deficit with China. Essentially, America buys far more from China than China does from America. That means that cargo ships from Greater China travel to the US almost completely full, but then return with plenty of extra capacity, meaning shipping rates to China are far lower than shipping rates from China. Thanks to that, you could get one of those MRF residual bales across the Pacific for next to nothing. In addition to this, since the 1980s, China has been riding its way through an unprecedented phase of economic growth. This was so dramatic that the company's industries literally could not find enough raw materials, including plastic, to fulfill their demand. Therefore, with constrained supply and high demand, even recycled plastic prices went up, giving the recyclers in the country more room to cover costs. In addition, especially in more rural areas, wages were low in China. Those MRF residual bales are composed of those difficult-to-sort plastics, but humans can sort just about anything profitably as long as their wages are low enough. So, all in all, considering shipping to China was effectively free and raw materials were higher and wages were low, the equation just happened to work out that in the late 90s, 2000s, and early 2010s, sorting and recycling MRF residual bales in China was just ever so slightly profitable. That's why, upon arrival into Hong Kong, the plastic yogurt container disposed of in Littleton, along with everything else in these bales, is immediately transferred onto a smaller barge and re-exported out of Hong Kong for a short journey across the Pearl River Delta to the Guangdong province in mainland China. Then, after an 8,000-mile, 13,000-kilometer journey to the other side of the world, it ends up at its final destination: the Welpine Plastic Industrial Company just outside Guangzhou. There, the bales are unloaded, spread out, and low-wage workers manually sift through the contents, eventually finding that yogurt container and putting it in a pile along with the rest of the polypropylene plastics. From there, the polypropylenes are melted down, purified, and reformed into pellets, which then, eventually, are sold in bulk to another manufacturer somewhere else in China for a very, very slight profit. Now, this whole system of taking effectively valueless MRF residual bales and shipping them across the world to a place where they did have a very slight positive value worked. It wasn't elegant, it wasn't clean, but it worked. And that's how, for a few decades, the Western world's recycling system functioned. The most valuable stuff was sorted and sold domestically, the valueless stuff was exported to where it had value in China, and the stuff with a negative value was sent to the landfill or incinerated. But then came that document. The notification to the World Trade Organization Committee on Technical Barriers to Trade. All this said was that China would, starting at the end of 2017, ban the import of 24 products covered under these HS codes, the numerical classifications used to simplify international trade. These particular 5, though, were the ones that created this big problem for the plastics industry. They translate to waste, pairings, and other scrap of polymers of ethylene, of polymers of styrene, of polymers of vinyl chloride, of polyethylene glycol terephthalate, and other waste, pairings, and scraps of plastics. Effectively, by banning these 5 HS codes, they banned the import of almost all plastic waste. As a result, the country's 2018 plastic import volume dropped 99.1% compared to 2017. This massive global industry quite literally ended overnight. Now, while the true reasoning behind any Chinese government decision is always elusive, at least according to this document, it was that the import of these products was creating a serious environmental and public health problem. This is likely true. As MRF residual bales are, by their very nature, unsorted, they often included hazardous materials that could seriously harm those sorting them, and this went on to cost the government since the government runs much of the country's healthcare system. In addition, the sorting facilities in China would often illegally dump the portion of the plastics that even they couldn't profitably recover, creating an environmental problem that the government had to pay to clean up. Therefore, while the private companies that actually sorted and processed these MRF residual bales turned a slight profit, China as a nation was losing money by processing the world's trash. So, essentially, even though it looked like plastic recycling was profitable, once the externalities were priced in, it once again became clear that plastic recycling was not, in fact, a viable system. That's why China issued this document, that's why they banned plastic waste import, and that's why the world's recycling system broke. Nowadays, when a woman in Littleton, Colorado throws her yogurt container into the recycling bin, the journey that ensues is often far, far shorter. First, as before, it's picked up by a truck, brought to a materials recovery facility, sorted down, and packed into one of those MRF residual bales, but after, there are now 3 main options. The first is that it's exported, as before, but not to China. In response to the import ban, Malaysia tripled their plastic import volume between 2017 and 2018, becoming the largest processor in the world, and some other nearby low-wage countries ramped up as well. Eventually, though, these countries will undoubtedly realize what China did. Processing MRF residual bales may be profitable to a company, but not to a country. The amount of health and environmental issues it creates in the long run costs more than the industry makes. Even despite the alternate plastic export options, the US's export volume, which includes more than just MRF residual bales, still dropped by a third between 2017 and 2018. There was just no one who would take these bales, even for free, since with the removal of China from the market, very few companies could turn a profit processing them, even outside the US. The global value of one of these bales went from slightly positive to clearly negative. And remember, recycling only works when it's profitable. Therefore, with far fewer buyers, MRF residual bales piled up and up until eventually, the waste processors gave up and put them into the same category as bottle caps, scraps, and those other small, unrecoverable, unprofitable pieces of plastic. Now, when you put something into one of those big blue bins that are supposed to lead to a second life for your waste, it ends up, more often than not, in the incinerator or landfill. Plastic recycling, with the exception of those few highest value items, is now definitively broken. But here's the thing. It was always broken. Plastic recycling, with limited exception, never generated more money than it cost, and so it was never economically sustainable. The China system was just a blip, thanks to a unique set of economic circumstances and a government that didn't yet recognize the cost of the industry's externalities. That puts the plastics industry back where it was in 1969. People are starting to realize that there is no way to make plastic sustainable. There are some half solutions. Some scientists are working to develop an enzyme that can eat plastic in a matter of days, and others are trying using chemical processes to break it down into its raw components, but the recycling problem is not a technical one. Actually performing the process of taking what's disposed of by consumers, sorting it, and melting it down into new raw materials is easy. What's not is the economics. The recycling problem is an economic one, and you can only solve economic issues with economics. The true solution is simple. Either the cost of recycling has to come down, or the price of raw recycled plastic has to go up. What's going to fix recycling is when it generates more money than it costs, but making that happen will take quite a lot. If enough consumers, for example, buy products that use recycled plastic rather than a direct alternative that uses the virgin variant, market forces will work out in a way that, eventually, once critical mass is attained, what companies lose from customers choosing more sustainable alternatives is more than what they lose from paying to swap to more expensive, lower quality recycled plastic. Plastics recycling, as a system, was never created to make the world a better place. Rather, it was created by the plastics industry to plug a hole in their system. It was created to propagate a false belief that consumption could be sustainable. So the only way to stop plastic from overwhelming our oceans, polluting our land, and making the world a worse place to live in is to shut the system, the entire system,